One of the core principles of good programming is avoid repetition. Say something once, why say it again? This is a big part of why loops, which we've just looked at, are as important as they are. This is good practice because, one, it saves space both for us who have to actually write it and the computer that needs to store it, and two, it just makes it easier to change later. We only need to change it in one place. In Python, say I've worked out a way to tell if a number is even or odd, and I write it in Python. But I don't just have one number I need to do this for. I have several. A for loop might help if they're all in a list, but what if I need to do this in two different places in my code? Then I'd need to write the whole thing out twice. This is where functions come in. In Python, we can write a small, or for that matter, a very large section of code and give it some name. We can then refer back to it using this name later in the code whenever we need it. A bit like how we store data in a variable for reuse, only this time instead of data, it's code that we can run. This is done using the def keyword, followed by the name we want our function to have, followed by brackets. And those brackets play a very important role, which we'll get back to in a minute. Function definitions, that's what the def is short for, by the way, also follow the same rule of code blocks as our flow control statements, like if and else, etc. See the colon and how the next line is indented. How does this help us with our even number example from earlier? Sure, we can write a function to tell us that 4 is an even number, and then we can find out that 4, in fact, is an even number as many times as we want, but that doesn't help us with any other numbers. Okay, so maybe we leave the definition of x outside of the function. Then if we need to, we can just change x. But now, isEven can't run without variable x. What if we need x for something else? Or if we forget to change it, or forgot to define it altogether? Sure, this works, but it's far from ideal. There's too many things that could go wrong. But lucky for us, there is a solution. And it's got everything to do with those brackets. Passing parameters. If we want our function to not just work, but work in lots of different contexts, we can start introducing parameters. A parameter is like a piece of information which needs to go into a function in order for it to know what it needs to do. And we use them pretty much just like variables, only instead of declaring and defining them, we just name them inside of these brackets. That parameter can then be referenced by name later inside that function code block. In order to run the function with a certain value, we write that value in the brackets when we call it. Again, remember the rules of scoping. This function definition has its own block of code, meaning that any variable names are local to it. If we try referencing a parameter or any other variable for that matter that we define inside of that function, after we've exited the block of code, we'll get an error. We can now apply this to our isEven example. See now how x is a parameter, meaning it will take whatever value gets passed to the function each time it is called. We can now use this again and again, whenever and with whatever other number we want, passing whatever value we need, i.e. the number we want to know whether or not it's even, as the argument each time. We want to avoid a misconception you might have at this point. Parameters are not the same as variables we define ourselves. They're similar, but not quite the same. The important difference is how they're declared. While variables require an explicit value to be defined as, the parameter just sort of waits to be given the value that is passed to the functions. For this example, x is sort of left blank until the function is called, at which point it takes on the value of whichever argument was passed in the brackets. Multiple parameters. It's important to remember that whenever we call a function, it needs to be passed the right number of values. That is one for each parameter we defined. If we forget to do this, we get an error. I say the right number of because we can define functions with as many parameters as we want. That is none, one, or many. If we have more than one parameter, we just need to make sure that they have different names and are comma separated. Also remember that the order is important. Arguments must be passed in the same order. Return values. So far so good. But take a look at this. We're going to use our function as the condition in an if statement. It's obvious what we're trying to do. We have a statement that we want to trigger if 2 is even. But there's a problem. We know that if statements need Boolean expressions, or at the very least, some value that can be cast to a Boolean. Is even 2 isn't a Boolean, it's a function call. If we try and run this, by definition, Python will read just ordinary function calls as none, which it reads as false. But this is ridiculous. Is-even does tell us whether or not a number is even. That's what the print statement is for. Remember what we said all the way back at Hello World about print statements. They are meant for us, the human reading what the code is doing on the command line or the output. Printing doesn't tell the program itself anything, and we can't make the program read back what it's just printed, at least not without an awful lot of work. What we want is our function is-even to somehow give us an actual Boolean we can use and that is either true or false, not just false all the time. So what can we do? Well, we know we can use parameters to pass data into a function. Is there a way we can define what data we want to come out of a function? This is what we use return statements for. The return statement is actually very easy to use. You just write the return keyword, followed by the value you want to come out of the function. Once the function hits a return statement, it will exit out of the call with whatever value it's been given. This value can be a variable, an expression, even another function call. Here, we're giving it a literal Boolean. Now, depending on what value x is passed to it, is-even will output either true or false. It's ready to be used in an if statement. Recap. Learning about functions is probably the biggest leap forward we've taken since we started all the way back with Hello World. So it's okay if it takes a little while to properly sink in, or if you still have questions. We're going to take just a minute to review. Recall all the way back to learning expressions for the first time. We said that any expression, no matter how long or convoluted or impenetrable it looks to us, at runtime, that is to say when the program runs, gets evaluated down to a single value. Functions and function calls work in much the same way, where the value that they are ultimately evaluated to at runtime is the value that the function returns. This works no matter how many or how few parameters your function takes or what it does with them. And maybe now you're wondering, do we need a return statement? Earlier we left it out and it worked just fine. Well, no. If a function has no return statement, like we just said, it gets evaluated to none. Summary. In computer science, we like to generalize functions as a sort of black box. That is, when we call a function, we put values in, and a value comes out again. Once we have that final value, once it's been returned, we no longer know, nor should we really care, about exactly how the function worked inside. Which isn't to say what a function does isn't important. It's hugely important. The return value needs to be correct, i.e. it needs to do what we need it to do, and it should be done in as efficient of a way as possible. But these are all things to consider when writing the function, and before we run and call that function. With this, we've covered all the fundamentals of functions. Now will be a great time to do some exercises, to see how they work for yourself, and hopefully to strengthen your understanding as much as possible.